Well, today is the first episode of the new year for the main show. So today I thought it'd be really fitting to talk about a recap of the discoveries made by the James Webb Telescope. 3 years of discoveries, rounding out, those 3 years and, potentially what we can, potentially see in the night sky, within the next year. Thanks to James Webb. In the sky report, there's not much really happening this week. It's, I guess you would say like a normal sky, just normal activity. No full moons, nothing like that, but I'll get into that a little bit later. And we're also going to be talking about the confirmation of the existence of fast radio bursts. These mysterious radio bursts that, seem to have no origin, have been discovered, where their origins are, and, we'll talk more about that when we get to it. But anyways, we're going to be talking all about that and more. This is Interstellar Insights. Alright, so despite me saying that we were going to talk about James Webb first, we're actually going to talk about today the fast radio bursts, or FRBs, these mysterious bursts of radio light that, are getting unraveled in truth, if you know what I mean. But, to start off with a little bit of context, fast radio bursts are flashes of radio light taken outshine in a galaxy. But since they're obviously fast, they only last like about a fraction of a second, which make them, incredibly hard to study given the amount of information, we can pull from that. But thanks to technology, mainly, regarding wide field radio telescope. No, not telescope. There's a bunch of them. Telescopes, absorbing all these radio waves out in the cosmos and, relaying that information back to us. The biggest example is the Canadian Hydrogen Intensity Mapping Experiment, otherwise known as CHIME, located in British Columbia. We have a general understanding, to the cause of FRBs and, where they're located. Also, shout out to Stanley and the people of his people of Canada for doing this, because I think this is the only time Canada is going to get mentioned. Although I don't know if I mentioned Canada in the past, but there you go, Stanley. You get your moment of glory on the normal show, but I'm getting off track. Right now, actually not right now. FRBs, usually they'll occur in very distant galaxies. And of course, to travel between a very distant galaxy and here on Earth, you need to go through the interstellar medium, aka just, space. That's how light travels. Well, I guess the best way to put it is that the medium for sound to travel is not interstellar space, but it's actually like air. So, the reason why you can't really hear sound in space is, because of that lack of air. But as FRBs, travel from distant galaxies to Earths, or not Earths, just Earth. There's not more than one Earth, although that could be coming soon. Who knows? But, as they travel, the FRBs travel from distant galaxies to here on Earth. There's a bunch of different factors, mainly like gas and dust from, other objects that the FRBs might pass by that'll distort the wavelengths. So if we kind of reverse engineer, and, understand, what factors distort what parts of the wavelength for FRBs, we can understand, where it originated from. A prime example is, using light to study origins, like stars and planets. Planets will usually appear as a disk of light. So that's how, you can differentiate planets in the night sky. If you look up compared to a star, which is just a dot, because that is like a light, a source of light, whereas, a planet, light from other stars in the sun, you just kind of cascades over the planet. So, get that disk-like effect in the night sky. Excuse me. with this methodology, in mind, there was a team, and it's like a cracked astrophysics team. They published their studies in Nature, and they were able to analyze, the scintillation, which is just a fancy word for like a flash or a sparkle of light. In this case, from the FRB, they were observing. I guess I'll backtrack here. This team was observing one of these FRB radio bursts. They called it FRB 2022 102022A. I don't know why it's called that. Probably because it was discovered in 2022. No, no, I'm losing my mind. No, what I meant to say is I don't know why. It's just like the rest of astronomy, and they can't name their bull crap together or whatever. No, but this was the particular FRB burst that this team was studying, and from that they discovered that FRB 2022-1022A, and that's like the last time I'm saying it, originated from a magnetar. And for those of you that don't know, you have neutron stars, which is when a star collapses and it collapses on itself. The neutrons are like the last barrier that stopped that force, the force of I guess the force of collapse. The neutrons are the last kind of barrier before total collapse of the star's core, of course, which will end up in a black hole. No, but there's many different types of neutron stars. Of course, the most obvious one is pulsars, which will like emit like X-rays. I guess they won't emit like gamma rays, but they will emit like just waves on the EM spectrum that we can pick up. And then magnetars are like a step up in terms of like strength, because they have a really strong magnetic field, so they can really emit X-rays and gamma rays and all the higher length wavelengths, if you know what I mean. So yeah, so this while this particular FRB was discovered to be a magnetar, that still leaves a lot of questions if all FRBs originate from magnetars, or if there's other celestial objects that they can originate from. But very interesting, kind of a first step to studying FRBs, and if we can get a general idea, a much better idea of how they form, or if it's just like I said, if it's just magnetars that are like this. So yeah, with that being said, let's go move over to this week's Sky Report. Well, guys, welcome to this week's Sky Report. As always, and this is probably the first time this year, and probably the last time I actually say this on time, but all times that I say are going to be listed in Eastern Standard. So if you don't live on the East Coast of America or Canada or whatever, that's a you problem. Go figure it out in your own free time. I'm not responsible for that. But anyways, let's get started to it. So today, Wednesday, January 8th, there's actually, yes, I guess it was up in the morning, but I can't really say for sure. But tonight there's going to be a deep red carbon star, which will be up in the night sky, R Leporis, which is also known as Hin's crimson star. It'll rise about 20 degrees high in the horizon 2 hours after sunset, and it's just going to be to the right of Regal, which will be shining at a magnitude of 0.2. I don't know why that's hard for me to say. But I guess this is the first time I really mentioned carbon stars, and this was kind of for me when researching this. This is kind of like my first segue, because I never really heard of a carbon star, but carbon stars, they'll appear red in the night sky, mainly because, like I said, they have a bunch of like carbon compounds in the star, and then with that, they're able to absorb shorter wavelengths of light. So just kind of a quick lesson on the EM spectrum. Light like green, blue, and purple, they'll have shorter wavelengths compared to like orange, and red, which will have longer wavelengths. So, hold on, ooh, my microphone. I got a new stand, so I got to adjust. Where was I? Yeah. Lights, green and blue light, that's more likely to get absorbed by these carbon compounds. But red light, that's not going to get absorbed because it just has a longer wavelength that'll allow this red light to pass through, and we'll get to see it in the night sky. But yeah, that's all happening. That is happening tonight, Wednesday. Thursday, tomorrow. There's a lot of things going. Man, this might be the most exciting night. But the moon is going to pass 4 degrees north of Uranus at 11 a.m. Eastern. So in the morning. I don't know why I said Eastern. But a few hours later, the moon is actually going to occult several stars in the Pleiades star cluster, otherwise just known as the M45 star cluster, which is going to be visible everywhere except for if you're in Pacific time. I guess not in Pacific time. Just in the Pacific general, if you're living in the West Coast, you'll be fine. No, but if you're here on the East Coast though, we'll get to see some stars disappear, such as a 4th magnitude Electra. That'll be the first star to disappear behind the moon at about 7. And then about 20 minutes later, Merope is going to disappear as well behind the moon, as part of the alkylation, I believe. That's a proper alkylation. I don't know. Turning a verb into a noun, occultation, I don't know. But this is one of many, I guess it is oculations that are going to happen this year in the night sky. I'm pretty sure it's the first one, because I wasn't able to keep up with the sky report for the past last week, but that's a story for another time. Anyways, finally, Friday, starting off at night, the moon is going to be active again, as it will pass about 5 degrees north of Jupiter at 6 p.m. And then Jupiter and the moon are basically going to be in the night sky, all night long. Other stars are going to be present as well Friday. Gemini is going to be present to the lower left of, Taurus and, Taurus the bull. And then Taurus itself, the star. Hiccups. At the top of those two stars, Castor is going to be present, shining at a magnitude of 1.6. And then just above Castor is going to be a magnitude 1.2 Pollux. And then below, to the left of both Castor and Pollux, is a very brightly shining negative 1.3 magnitude Mars, which kind of sounds strange just from the context, since I was just talking about stars. It's like Mars just came out of nowhere. Yeah, but anyways, like I said, very brightly shining, negative 1.3 magnitude Mars. That's going to be shining a lot of yellow light towards us that night. So very easy to spot. Just look for a giant disk of yellow light. Basically, yeah. But anyways, now for some actual times. January 8th, sunset's going to occur at about 4, I guess that's today. I don't know why I said January 8th. I don't know. Sunset's going to occur at 4:52 p.m. Moonrise is going to occur at 12:14 p.m. Moonset's going to finally occur at 1:53 a.m. Tomorrow, the 9th, Thursday, sunrise is going to occur at 7:22 a.m. Sunset's going to occur at 4:53 p.m. Moonrise is going to occur at 12:49 p.m. And moonset's going to occur at 3:08 a.m. Finally, this Friday, the 10th, January 10th, sunrise is going to occur at 7:22 a.m. Sunset's going to occur at 4:54 p.m. Moonrise is going to occur at 1:32 p.m. And moonset's going to occur at 4:24 a.m. So, yeah, those are your times. And then the phase of the moon this week, that's going to be pretty much the same throughout, is going to be waxing gibbous. So that'll be what is present basically for, this week. But anyways, that's this week's Sky Report. Let's go move on to our, second topic, that very important second topic regarding James Webb Space Telescope. All right, guys. So, our second topic, I don't want to call it a year in review because this is really more of I guess the best way to put it, it's kind of like a total review of James Webb over 3 years. So it's not really a year in review; it's more like 3 years in review. That would be a funny title for this episode. 3 years of review. I don't know, but there's been a lot of stuff discovered by James Webb. But before we begin, I think it's important to talk about the actual Space Telescope and how it was created and the dawn of a very, very, very impressive piece of technology in our understanding of space that's in our arsenal. So James Webb Telescope, it's been running for 3 years now. JWST actually took 30 years to build by NASA. And it's only it's only been in space for 1/10 the time it took to build. So that's something I really didn't know until researching and talking about Webb. But that's just impressive. So this is very top of the line. But during its 3 years, as kind of a summary as a whole, JWST's really just contributed to our general understanding of the cosmos. By looking at ancient galaxies to show how they formed 300 million years ago. This information is actually pointing towards a couple of I guess space mysteries, if you will. Cue scary music. I don't think that's going to happen. Just use your imagination. Maybe someday. But anyways, one of these mysteries regarding the galaxies is the potential theory that early galaxies were actually very blue. So, James Webb, the JWST, observed these ancient galaxies. And from these observations, they determined that, there was very little dust, mainly because of the blueness, because these galaxies were super blue, and blueness genuinely indicates little dust, as I repeated myself. But this just raises a question of how exactly these galaxies, how they grew. Mainly because they grow through like star explosions and the birth of stars, and usually that'll leave like a bunch of dust, like a dust trail within the galaxies. But since we can't see any dust, it does raise the question of how that occurs, which will be something that astronomers will probably look into this year, as well as James Webb, finding more, doing more observations, tailoring results and stuff like that. But yeah, there's like two more. Another mystery that has really opened up thanks to James Webb is the chemistry of early galaxies, because if we know anything about the Big Bang, the first elements were really hydrogen and helium and lithium, which are still the most predominant elements in the universe today. Most of the other elements, there's very sparsely, like it may seem like we have a lot of carbon, but because if you think about it, trees are mainly carbon, because they breathe with carbon dioxide. That's biology. But just looking at the amount of trees, that's only like a small fraction of the amount of matter in the total universe. That's carbon. Just all the trees on Earth. But that's just me pushing it with Big Bang chemistry. But the unusual thing is besides the typical hydrogen, helium, and lithium, JWST observed high levels of nitrogen within these early stars and within these ancient galaxies, which is very strange because, nitrogen has like a much higher atomic number piece. Hydrogen has an atomic number of 1, helium has an atomic number of 2, lithium has an atomic number of 3, and, most of these elements would have been formed through nuclear, fusion and stuff. Not really my tempo of what I deal with, but I'm sure you guys understand what I mean. It's just that the fusion wouldn't have happened in time for there to be nitrogen within these early stars. Finally, there's also these mysterious red dots in the night sky. And I know what you're thinking is that these are actually UFOs. These are signs of alien life, and this is all a big government cover-up. Except it isn't, because, looking at it, there's a bunch of prevailing theories besides the obvious alien conspiracy theory by a bunch of level-minded astronomers, is that these could be just really massive, ancient, super dense galaxies or supermassive black holes. But the properties of these red dots, it's just so hard to tell like their traits and stuff, because there's a lot of like paralyzing and contradictory properties of both like super dense galaxies and these supermassive black holes. So it's hard to say what exactly these objects are, but this is something looking forward into next year, what a lot of astronomers are going to tackle with. Hopefully maybe we'll get probably by the end of 2025, maybe another episode, talking about Webb this year and the discoveries it's really made, mainly because there's still a lot of left to discover in the universe. We've only scratched it, so Webb can really help us. And then of course we have all this fancy all these fancy mysteries that need to be dealt with and solved. So yeah, but anyways, with that being said, with James Webb Telescope's 3 years in review, let's go move on to this week's edition of Astronomy Trivia. Alright guys, welcome to this week's edition of Astronomy Trivia. Before we talk about this week's question, we're going to pedal back to before break and talk about that week's astronomy trivia question. The one from last year, I can say that. The last year's astronomy trivia, I can say. And I believe the question was regarding which moon in the solar system is known for having methane lakes. And so the answer to that question is obviously Titan. For those that don't know, Titan is the largest moon in Saturn. And I'm assuming it's either the second or third largest. I think Triton is somewhere on there. And then, of course, Ganymede is the biggest moon. Because Titan is larger than the moon and Mercury. But it is slightly smaller than Ganymede. However, the surface of Titan is just covered in these hydrocarbon lakes, seas, rivers. Of course, methane is a hydrocarbon, so methane is the most prominent, as well as ethane. Those two are very prominent on the surface of Titan. So, that's led some people to believe actually that Titan could potentially support life. It's one of those objects, next to like Enceladus and Europa, that could potentially support life within the solar system. But anyways, moving on to the new year. So new astronomy trivia question. I'm going to read it a couple of times and but anyways, the question is, which moon in the solar system has over 400 active volcanoes? I'm going to read this again. Which moon in the solar system has over 400 active volcanoes? I'm going to make a poll for both YouTube and Spotify, and I'll let the respective viewers answer each of their own polls. But anyways, let's go close out this week's episode. Well, guys, close it out. Obviously we've reached that point, the end of this week's episode. So next week, regular song and dance, regular schedule. Getting back into the swing of things a little bit with school. So, it's it's been a little bit tough, but I've been getting back into it. So yeah, and then of course we're going to have a bunch of bonus episodes. I'm trying to keep it at least one per week, but we'll get a wide variety of guests on. Talk about things outside of astronomy, because there is more that I do than just astronomy. It's obviously not like I'm like stupidly devoted to astronomy, but I am devoted enough to do this. So just little other things that I find important. But and then of course we've got shorts. I'm gonna try. The issue with trying to incorporate shorts from the main show as opposed to the bonus show is that a lot of this is really just timely. Because the news is only going to be relevant for a little while, before, it fades from obscurity. So, but I'm willing to try, maybe make an interesting short or two, or I was thinking of, doing shorts, explaining, various topics of the, universe besides from the bonus show, or just, read clips and stuff like that. But, yeah, that's all I have got. If you enjoyed this episode, hit the like and subscribe button. It doesn't take a lot out of your time just to do those things, and it really benefits me a lot. So I would very much appreciate that. And then of course, go follow our Instagram. And yeah, I guess it is. Guess till I see y'all next week. This is Michael signing off.